And our next speaker is Adam Bender, principal software engineer from Google. And he has a really great topic for the career track about software engineering, and that's it, decision making. Hi, Adam.
Hello. Can you hear me?
Yes, I can hear you. I can see you.
Woo!
It's great. How are you?
Lovely. I'm doing well this morning. How are you?
Also great. Thanks.
Excellent.
And yeah, let's start. I'm sharing a few slides, and the stage is yours.
Oh, thanks. How exciting. Hi, everyone. My name is Adam Bender, and uh, as was mentioned, I'm a principal engineer at Google. And perhaps more relevant for this talk, I'm also our code health practices lead. So it's my job to think about how we make better software long term at Google. We have a lot of code, and thinking about how to make it better is apparently a full-time job. So today, I want to talk a little bit about what I see as a different way of thinking about software engineering, different than I think we teach, different than the way we talk about it. To me, software engineering is about decision making. Now, before I explain what that means, let's take a look at some code, right? This is a software engineering conference, so it would be wrong of me not to have at least some code to share. So here's a couple C++ functions, and I'll state for the record, I am not an expert in C++. I know enough to get this code properly formatted on the screen, but there's some interesting properties in this code that I think you will all see whether or not you speak C++ fluently. So the first question is, how many decisions were required to write this code? When you look at this code, how many distinct decisions do you think it required to get it written? Well, let's highlight a few. First, we had to choose two function names, in this case, create and get new transaction ID from monitor. Then we had to choose two return types, two different preconditions. There was a decision to perform a retry loop. There was a decision to name a local variable. All of these are very, straightforward kinds of programming decisions. There, of course, was also one decision to compose this work into two functions in the first place, which probably involved another decision about choosing where to do the different precondition checks. There was a decision not to create or handle any kind of errors in this code. There was a decision that every new workflow that passed through this code should have an ID. There was a decision made that ID should be a global ID, and that ID should come from the global ID service, right? And I should point out that these are all the decisions we can see. Who knows how many it took to actually work through, or how many decisions were made in the process of creating this code that we don't see because the author decided to do something different, right? There's some other harder to see choices, right? There's the decision to use C++ in the first place. There's the decision on how to do indentation, the decision to use underscores for local variable names, a decision to use capitalized words for function names. And you may say, but those are obvious choices. Those are probably in a style guide. Sure. But a style guide is really just a collection of somebody's choices, some decisions that someone had to make, right? There are even more difficult to see decisions. Things like, why was this work prioritized in the first place? Why should it be located in this file? Why should it live in this service? There were decisions about how to test this code, how to compile, ship, and support this code. And of course, you can't forget all the decisions you depend on that led to the design of the language and all of the tools necessary to express it in the first place. That's a lot of decisions, right? That's a lot of decisions. And to my mind, this speaks to a really underappreciated point about software engineering. And that is that literally everything in software development is a decision. I just covered 20 plus decisions for 20 lines of code, right? Now, some of these decisions work out just fine. Some of them do not. Can you see the one decision that led to 130-minute downtime and many, many dollar signs of outage for YouTube? It may not be obvious if you're not familiar with the code, so let me help you out. It's right here. See, the root cause of this issue was that an API, which was designed for low QPS usage, this new global unique ID, it was designed for circumstances where you would occasionally sample like 0.0% of all traffic and call this method. That's what it was intended for. We had a change which accidentally put it on the request path for every single request. So this low QPS usage suddenly became very high QPS usage, right? In this case, QPS stands for queries per second. And I can't tell you the specific details of what went wrong beyond this, but I can tell you it was bad enough that YouTube ended up in the news that day, right? Almost anyone making this change, the change here in this code, would have had a hard time recognizing the cost of the mistake they made up front. Sure, you could argue they could have had better testing or better developer documentation. I actually don't think either of those remediations would have guaranteed this problem goes away. See, the impact of this change was magnified by several factors that were not immediately in evidence to the change authors, and it's very likely they could have imagined this test scenario ahead of time. After the fact, obviously, it's clear what went wrong. But as many software engineers, as any of you probably would confess, it's very hard to know for a given choice which one is going to be the bad one ahead of time. So I've said the word decision a bunch, but I should probably define it a little bit. When I use the term decision or decision making, what I'm referring to is a sort of process that looks like what I have here on the right. It's a process where you define a question, something you need to answer, some choice you need to make, something you want to do. You gather some data about that choice. You refine the available options to try and narrow down to a set of things that you think might be good. You eventually commit to one of the options, right? That's making the decision. You probably communicate that decision to other people. And then if you're doing it right, you evaluate the impact of that decision for future use, right? It's no good making a decision and not learning from it, bad or good, so that you can do a better job next time. Now, decisions ranging from the trivial, like what to eat for lunch, all the way to the complex, like what data store should we care about for this, for this new system we're building, they can all be mapped back to a process like this. Obviously, more complex decisions have more going on, but I'm pretty sure that nearly every decision you make will eventually go through most of these steps. Now, it does go without saying, I'm pretty sure, that decision making is sort of a self-evident activity. We make decisions so frequently in day-to-day life that it's kind of hard to see it as a thing with parts, right? It's hard to break down a decision into these individual steps, which makes it hard to learn how to get better at them, right? That invisibility camouflages the fact that decision making is a skill that can be learned and can be optimized for. Getting better outcomes from our decisions is possible by improving the outcomes for each of these individual steps. So that kind of begs the question, how did you all learn to make better decisions as a software engineer? Maybe you took some classes. I mean, I've never taken a class on decision making. I'm sure one is offered out there, but maybe that's what you did. Maybe you had a really good mentor. Maybe you had someone who happily spent time explaining all the things that they had made mistakes on in their career and passed on all that wisdom to you. That'd be amazing if you had such a mentor. More likely than not, though, you went to what I call the school of hard knocks, which means you made a lot of decisions. Some of them went poorly, and you learn not to make those mistakes again, right? In other words, trial and error is really the best tool we have for teaching people how to make better decisions. I don't think that's good. I think we can do better than that, right? I don't love that we seem to lack a really good idea about how to train software engineers. Now, you might ask, why does this matter to software engineers? We just write code. Well, in my work at Google, I study a lot of different projects. I look at projects that are doing well, projects that are doing poorly. Nearly every project that I look at, nearly every time I talk to a team, there's some form of decision fatigue that seems to be plaguing them. Decision fatigue meaning just the sheer number of decisions that they have to make to get stuff done starts to overwhelm them and make it difficult to make progress. Right? So, as I said before, nearly every act of a software engineer requires making a decision. And every decision that you make is built atop a mountain of previous decisions, each of uncertain quality. You don't really know how the libraries you depend on were built. They work, thank goodness, but you can't really vouch for the quality in the same way, or in the same way you can vouch for your own code, right? We also have no laws of physics in software engineering. There are no hard rules except maybe the speed of light and the speed of your CPU, right? Everything else from there on is an arbitrary set of decisions. The only constraints are those that we decide which should exist. We can make pretty much anything, any set of abstraction, any shape of code. We can decide any sort of concepts are the way we want to build our system. There are no real constraints. And that's sometimes why using new tools or languages can feel like all you're doing is just trying to memorize tons of arbitrary rules, tons of random facts that help you to make progress learning the language. It's kind of a daunting experience sometimes. Our decisions are also risky and expensive. They're risky, in my opinion, because we don't really have a mature approach to making decisions. The best tools that we really offer ourselves and our colleagues are things like Yagni, or you ain't gonna need it, and Dry, don't repeat yourself. And these are clever little slogans, and there's some truth to them, of course, but they don't really offer you a clear strategy for how to apply in uncertain circumstances. Like, how many times is too many? What does it mean to repeat yourself? All of this is entirely left up to interpretation by the people who are trying to use these tools, right? All our decisions are also interconnected. A decision about a low-level API can affect an entire company or an entire ecosystem. JavaScript. Uh, we can't predict which decisions are going to be consequential from the get-go. Simple errors like the YouTube bug that I showed you caused a massive impact. But we often don't know ahead of time which of the tens of thousands of decisions we make will be the cause of the problem. So those risks create costs. Those costs come for a couple different reasons. First, if getting a decision wrong is really expensive, we're going to invest a lot of time up front trying to figure out how to mitigate the potential impact, right? And this isn't strictly bad, but because so many decisions can go wrong, we spend an awful lot of time trying to analyze, or at least I hope we spend time trying to analyze all the things that could go wrong, and that costs a lot of time and money, right? If each decision requires us to walk this tightrope between too much and not enough analysis, that can be wasteful. We're spending too much time on the wrong things or not enough time on the things that matter, but we don't know which is which. Imposing decisions also, or sorry, decisions also impose a cost on the people around us, right? When we develop software libraries or tools or frameworks, every decision we ask other engineers to make has a cost, whether it's a command line flag, a new dependency, confusing API name. All of these create cognitive load that may require extra days or even weeks to reason through. I'm sure all of you have had the experience of trying to make sense of a new API that just didn't seem uh, to make sense, right? It seemed confusing. There were too many options. You didn't know what they meant. Confusing names, duplicate stuff. We've all experienced that, right? And that cost adds up. The accumulation of all of these costs and all of this risk leads to a sort of risk-averse behavior and poor outcomes that I think overall slow projects down. The thing is that as our software systems grow, it becomes harder and harder to maintain velocity because our ability to reason about software deteriorates. The number of choices that we have to think about, both the ones that are in the past and the ones that are in front of us, just seem to never stop growing. Now, I find this interesting a little bit because in a lot of ways, everything that I've sort of described up to now is just what we call the job software engineering, keeping track of all these random facts and knowing which APIs do what. We've kind of defined the job of software engineer to mean someone who can memorize a bunch of random trivia and apply it when necessary. Now, I know there's much more to it than that, but honestly, how much of your time do you feel like you spend doing like real computer sciencey things versus just trying to remember how to make an API call, right? I don't think this is a good thing, right? Unsurprisingly, probably since I'm giving this talk, I think that we can do better. Now, before I tell you how, I want to give a quick aside, a personal rant, if you will, on something that I call primitive obsession. I borrow this term, by the way, uh, from a sort of design pattern smell of the same name, which tries to emphasize the problems you run into when all of your code is defined in terms of primitives and you haven't built up any higher levels of abstraction. That's where the name comes from. So, in my opinion, we have a sort of primitive obsession going on with the way we do software development. What do I mean by that? Well, we have long celebrated the kinds of software engineers that excel at accumulating random bits of trivia. Our languages, libraries, and tools are littered with random inconsistencies, poor names, and undocumented behaviors. Successfully navigating even a small project often requires committing to your memory all manner of code paths, URLs, special cases, historical footnotes, config locations, and more. And it's not just that we have hundreds of details to keep track of. We are hopelessly reliant on informal mechanisms to convey all the details of our systems because we have not developed the tools or the culture that make doing otherwise easy and valuable. Have you ever found yourself staring at a new code base, or maybe just one you haven't looked at in a while? And if you've been given the task of adding a new feature, what are the tools at your disposal to help you make an informed decision about any impact that your changes might have? For most teams, the answer is go and talk to the developer that's been on the project the longest. I got to say, this is not a systematic solution to the problem of knowledge management. This is how we maintained history prior to the invention of writing. We can do better than that. So, what is the impact of operating at such a low level of abstraction? Well, in many cases, it means making many more decisions, right? At a low level of abstraction, everybody has to make the same decisions over and over again, often with little context. It means each developer has to reason about the inconsistencies, which pattern should be followed. Is this change worth putting behind a flag? Where should this code live? And many times there's no real good reason why things are the way they are. That's just how we've always done it. The sum total of this sort of decision space that we inflict on our fellow software engineers has a tragedy of the commons kind of an effect, right? What's the cost of defining one more config option when you already have to memorize 100 or 1,000 other bits of esoteric knowledge? We are writing code and designing systems with tools like text editors and line-by-line debuggers that have existed for nearly 50 years and which operate at the level of, something like an amino acid, when our most complex systems have emergent properties that feel more like complex life, right? The thing that frustrates me is that we know how to build better tools, and we tried tools that operate at a higher level of abstraction. Unfortunately, we have also created really powerful social archetypes for how the wizened bare knuckle engineer works, and it's always a multi-monitor setup covered in reams of plain text. Those archetypes have power. They've come to define what real engineering is, and they frame how new engineers aspire to do their job, right? It becomes the ideal for thousands of new engineers. Here's the reality. Today's systems contained millions and millions of lines of code, written in dozens of languages. They may be spread across millions of individual processes, thousands of individual servers all over the globe. We cannot hope to reason about the trade-offs required when making decisions in a system of this magnitude if we are still trying to reason about our code one file and one line at a time. No disrespect to my VI and Emacs users. I know you love your tools. I just want us to find a way to build software systems and to think about them at a level above the plain text. All right. Thank you for permitting my rant. So here's the question: like, what can we do about this? How do we think about this problem? Well, here's a simple suggestion. Why don't we center the concept of decision making in the software engineering process? What if we talked about it more? What if we made it a central activity, something that we trained people for? What are the implications of taking decision making seriously as the core activity of software engineering? Well, here's some thoughts that I have about this. First, we should all become students of decision making. You can't and won't make every decision personally. So you need to find a way to learn from what others are doing. You need to discover what problems they're having, what decisions they're making, what are the outcomes. Take an interest in how decisions are made, what the decisions are about, how things went, right? You have a wealth of information around you. There are decisions being made around you all the time. Learn from that. Like I said before, heuristics such as Yagni or Dry, they're valuable, but they're poor guides for rigorous decision making. We as an industry, and I'm not just talking about academia here, we who are building software every day need to invest in understanding how to make better software decisions. We should really study this process and see if there are tools that we can develop to get better outcomes. Now, keep in mind that better techniques here doesn't just mean more and longer analysis. I'm perfectly aware that we still need to move fast. So we need techniques that are both good and fast, allowing us to deliver higher quality software faster. One of the most effective tools I've seen in my time at Google is the embrace of constraints, right? One of the most effective things you can do to make better decisions possible is reduce the number of decisions required to get things done. That way, your team's energy can be spent on the important choices. Now, reducing the number of decisions your team or others using your code will have to make will likely lead to better outcomes. That's what we've seen at Google, but it may mean less flexibility, and that may feel less exciting. The trade-off is it saves a lot of wasted time and reduces a lot of risk. Now, of course, there will be some cases where having flexibility is a good thing. The trick, and the real trick for any good software engineer, is figuring out where that flexibility matters. It's not uncommon that everyone working on a project feels like their project is the special snowflake, not realizing that they're probably actually a potato. And no one cares that potatoes look very different, right? It's just the way it is. If you own a library or service, maybe consider adopting something like a decision budget. Track the number of decisions that you impose on the users of your tools. Try to keep that number low, right? Constraints can help all of us reduce the space of complexity, reduce the set of options and the things we have to reason about, which makes it easier to get our jobs done. Now, making good decisions can't be done in isolation. If you really want to make good decisions, you need feedback loops. Feedback loops are how you drive the learning process. The good news for us is there's lots of opportunities in software development to introduce feedback loops. You can do things like code review, design review, post-launch reports, post-mortems, retrospectives. And something that I've been trying to pilot recently is sort of a long-range architecture review. In other words, you look at a system that's been running for 2, 3, 4 years, and you ask, how has it been performing? If we were to build this system again, would we do it this way? I think feedback loops are perhaps the most powerful tool for shaping how we make future decisions. Of course, if you want to have good feedback loops, you can do a little bit to help optimize for that outcome, right? You can improve the quality of your team's decisions by practicing a deliberate preparation for the eventual software archaeology that will happen. Your system is going to live for a long time, very likely, and that means you need to keep records of what's been going on for its entire life cycle. Nobody wants to inherit a system that's 10 years old and has no documentation, no evidence about how the decisions were made, no evidence about what choices had been made. If you really truly invest in documenting past decisions and putting them in a place where people can find them, you will help future maintainers, including yourself, when you come back to this project in a year, understand why things look the way they do, right? Importantly, when you're doing archaeology, or when you're preparing for archaeology, make sure that you document the why for your decisions. The what can sometimes be self-evident. We decided to use a microservices architecture, but the why is what really matters. That's where we start to understand the thinking process you had when you were building your systems. This will be incredibly valuable to someone who has to understand both choices they need to make, maybe in new systems they're developing, or ways to extend the system that you already built. And finally, as you might imagine, I'm a big fan of raising the level of abstraction of your tools, of your libraries, of your frameworks. You should work really hard to build higher level abstractions that let people working in your problem domain and on your system work at a level that's much closer to the problem domain itself rather than assembly code. Of course, it is entirely possible to go farther, right? Those tips that I just gave you are relatively simple. These are things that you can do tomorrow if you want to. They don't require a lot of additional effort. I know writing docs always seems like effort, but trust me, it's not relative to the time it saves you. But if we really want to change things, if we want better outcomes for software long term, I think we can go farther. I think we can start rethinking how we train software engineers. Right? I think we can reapproach the software developer education. I don't know about you, but my computer science education didn't really do a lot to prepare me for the kind of decisions I was going to be making as a practicing engineer, right? In my mind, computer science and software engineering have really diverged as skill sets. And I think there's something unique and different about software engineering that we aren't really talking about. To me, it's this fundamental idea that decision making, the ability to think about how to make choices in an informed and structured way is really missing. Right? So if we want to prepare better software engineers, here's some skills I think we might want to emphasize. For example, you could teach new engineers how to prioritize constraints. You've got a list of 10 things that you got to choose from. How do you build a prioritization function that lets you choose which options are probably the good ones? We can teach about the impact of cognitive biases, how to recognize them, what the impact of those biases are. We can talk about how to document and communicate decisions with the appropriate context. We could talk about how to think about the total cost of ownership of a decision, right? When you make a decision, it's not just the cost to implement, it's the cost to own that decision for 5 or 8 years that really adds up. We don't teach that today. We should. We can talk about how to classify decisions into types like reversible and irreversible. We can look at the effect that limiting choice has on the complexity of a system. We can teach how to assess the impact of decisions in a structured and blameless way. We made a decision. What happened? Let's look at it. How do we figure out what to do next as a result? We could teach the importance of situational awareness. How do you create an environment for better decision making? Right? How do you create an environment where you are consuming the right kinds of information so that your decisions are informed? And if nothing else, we should be teaching every new graduate of a software engineering school or boot camp or whatever how to uncover the decision-making processes going on around their organizations, right? Software engineering, as distinct from computer science, is not an iterated set of sort of tiny hackathon projects with discrete ends. Software engineering projects last for years. They come with things like maintenance and team turnover. They have to figure out how to adapt to an ever-changing world. That requires a different set of skills. Every choice in a real project carries consequences that will last for years. And that's something we need every software engineer to be ready to wrestle with. Now, our systems are not getting smaller, and absent effort, the rate of decision making, like entropy, is only ever going to increase. And all of this was bad enough with humans writing all the code, but on the horizon, AI is coming. It is going to change how we think about the role of a software engineer. And I think it could pose a potentially existential threat to our ability to understand the systems that we are working in. At their worst, an LLM is going to produce a ton of code at a rate never before thought possible by humans. Great. So now we're just making our systems get ever bigger. We're going to have to write LLMs to help us understand those systems. Where does it end? At their best, though, I think an LLM or any kind of AI could transform the experience of being a software engineer in a meaningful way, right? Imagine that everyone, new grads included, suddenly became the tech lead, the TL of a team of 10 intern level AIs. Instead of writing all the code, your job as a TL is to make decisions. Anyone who's a TL could tell you that. So that means everyone is suddenly responsible not just for making sure the code is written well, but deciding what code do we write, which part of the teams of these sort of AI teams are working on which problems. This is a really fascinating potential opportunity, but we're not ready for it right now. We don't prepare people to think about software engineering as decision making. Now, I think that we can improve our present and prepare for our future, right? I think we can start to study the role of decision making. I think we can center it as one of the most important things that every software engineer does. But to do that, we all have to take seriously the idea that software engineering isn't just programming, it's actually decision making. Thank you.
Thank you, Adam, for the presentation. It was really nice to hear your insights, your thoughts. Thank you for taking your time for educating us, and see you at the Q&A session, I guess.
All right. Bye.